So this video is going to be about constructive and destructive wave interference. So with constructive, just like the word says, you are actually building up, like two things are combining and becoming something greater. And in destructive, one wave is a little bit stronger and it kind of overtakes the other one. And we're going to explain this. What you're looking at here is textbook page 326 and 327. And I'm just going to read a little bit of what's going on so that you can get an idea. With this first picture here, you've got one wave that is going this direction to the right, and the other one is coming in from the left. And they seem to have similar, maybe slightly different amplitudes, but they're approaching each other, and the wave on the left has a slightly greater, just if you kind of look very closely, a slightly greater amplitude. So it's a little bit taller from the middle to the top. And then in the second picture, the new crest's amplitude is the sum of the amplitudes of the original. So you basically just add the crest or the amplitude of this one to the amplitude of that one. And now you have one larger wave. And in the third picture here, the two waves so they built up here and they've started to separate and they've gone back to their original size, except they have switched sides. So now the slightly larger amplitude is on the right and the smaller amplitude is on the left. And it looks as if they have not even met each other at all. Life just goes back to normal. So that's constructive interference. Now with destructive interference, what you're seeing happening in this first picture here is that one crest and one trough with equal amplitudes are starting to approach each other. And what that means is, as tall as this is, as tall as the crest is, that's how low the exact same thing the trough is. So the trough, the dip down, the trough is equal to the size of the rise up of this crest. So you've got kind of two equal things happening here. So that is the one crest and one trough with equal amplitudes approach each other. So that is what goes beneath this first picture. I'm just going to go ahead and stack it like this. This is number one. I'll stack number two and number three beneath. Now, number two, the picture for number two right here. So remember, the equal sizes, even though they don't look equal, this is just as high as this is low. They've approached each other. And in the middle, the crest of one wave is overlapping the trough of the other wave, and they kind of cancel out and they create this calm water. It might have some ripples in it, but it really doesn't look like a whole lot is happening here. So that is the second box that you're dragging. So that is this picture. So this looks almost like the resting point. Then in this third picture, the waves continue as if they had not met. So basically you're noticing that now the trough is on the left and the amplitude or the peak or the crest is on the right. That's the only difference. So they just kind of go on doing what they do and they just move on out. Now, the key here, when you see the red arrow is indicating the direction of wave number one. So we should know that that's the direction of wave number one. We always think the red in this picture is wave number two, or wave number one. And then with the blue arrow that's pointing this direction, this one, that is direction of wave number two. The red arrow that is pointing up is the amplitude of wave number one. And the blue arrow that is pointing down is the amplitude of wave number two. So you need to go back into your Nearpod and go ahead and check and make sure that you have these exact answers on your Nearpod for the slide that is talking about standing waves and wave interference.